Okay, so today we are going to talk about the real number system, okay, and different things like rational, irrational, integers, whole number, and natural number. These are the part of the family of real number system. Okay, so before going to the details of real numbers, I would like to introduce one more thing to you, which is called complex number. That we are not going to talk today because it will be like in 11th grade or 12th grade that you are in middle school. So I'll just introduce this concept to you, and then we'll go into the details of real number only. Okay, so complex number is combination of both real number and imaginary number. I'm going to define what is real number later, but first define. Okay, let's define the real number first, because imaginary number will be defined in terms of real number. So real number is anything that you can find on the number line. Okay, all the numbers, be positive, negative, rational, irrational, integer, whole number, natural number, any type of number that you can find on the number lines, that will be your real number. Okay. What is imaginary number? Imaginary number you can write in this form, like any real number multiplied by the square root of -1. Okay, square root of -1 multiplied by any real number, that will become your imaginary number. So let's take the example. Real number is 1, so that will be square root of -1. So square root of -1 is represented using I. Okay, maybe the first alphabet in imaginary, that's why they use I. So now if you want to represent any complex number, what you have to do is the real number here is a real number and B is also a real number. So let's say if I write here something 3 plus 4i. Look at the board. 3 plus 4i. This is a complex number comprising imaginary part and the real part. Why this is imaginary part? Because it has square root of -1. As I told you, imaginary number is nothing but real number multiplied by square root of -1. So this is your, if I write here -5, this is also an imaginary number. Anything minus square root 7. So these are imaginary number. So basically the number, this minus sign should be inside the square root. Okay. If it's there, anything 12, 15, whatever number you want, it's all imaginary number. And how can you write this one? You can take 15 square root times -1 square root. Look at the board. Can you write like this? This one, 15 square root times square root of 1. So this will be 15 square root, and the square root of 1 is I. So now we are not going into the details of imaginary number right now. As I told you, it's like 11th grade or 12th grade concept. So let's forget about that. Just remember that something is above the real number, which is called complex number, and it comprises both real part and imaginary part. So now let's move to the topic of the day, which is real number system. So I'm going to erase everything, but don't erase this concept from your brain. You just keep in mind that there is also a number system called imaginary number, but you don't have to remember everything about that right now. So now coming back to the real number. Okay, so as I told you at the start of this video, that any number that you can find on this number line, okay, any number. That will be your real number. Now real number, you can say it's of two types. One is rational number, one is irrational number. Okay? Irrational numbers are the numbers, if you solve this root, square root 2, square root of 3, pi or e, you will have something, let's say pi. Pi is 3.14, and then you will not have any repeating value anywhere. So you keep going, keep going, keep going, keep going. You will not find an end. As long as you want, you can keep dividing 22 by 7. You will keep going. Okay? So there is no end. Similarly, if you take the square root of 2, that will be your, I think, 1.414, and there is no repetition of any pattern. So you will keep going, keep going. So all these types of number where you don't have repeating pattern, if you solve, like if you represent that number in terms of fraction, you will have never ending series of digits. Okay, so that will become your irrational number. Despite that, you can find some place on the number line for these irrational numbers. That's why, yeah, even this number will have somewhere here between. Where do you think this will lie? So this will be here. Let's say this is 3, this is 4. This number is somewhere between 3 and 4. Okay? Similarly, square root of 2. It's here 1, here 2. So it's somewhere between 1 and 2. So this number also lies on the number line. It's not like this irrational number does not lie on the number line. It's there. That's why it's part of real number. Okay? Now, real numbers, you have everything. All the natural numbers, whole numbers, integers, these are part of rational number. Now, let's say something, this kind of numbers, if I remember from my top of my head, that something that can be repeated. Okay, so let's say some fraction a by b is there. Okay, look at the board. Some fraction right here, a by b is here, and what happens? You find c dot x y z, and then this x y g is repeating. Again, you will have x y g, x y g. These are the digits. Okay, don't get confused. Since I don't remember any non-repeating repeating fraction, so that's why I'm using a by b. Okay, if it comes to my mind, then I can tell you. But for the time being, just remember this is one fraction, and if you solve this fraction, you get all these are digits. A, B, C, X, Y, G are digits. So what's happening? You get some value here, and then you have some number of digits, but those digits repeats. Like here, you see, you have X, Y, G, then again you will get X, Y, G, again you will get X, Y, G. In that case, you can write like this. I think this is a symbol. Okay, so even this fraction is a rational number because you have the repeating sequence. Here we did not have the repeating sequence. You keep going, you can solve that for the whole life. Okay, you will not find the end. But here same sequence is repeated. That's why this became the part of the rational number. Okay, now you understood the difference between rational and irrational. And other than these types of fraction, you have any other fraction like 2.3, 5 by 2. You name any fraction that do not have that non-repeating sequence, like you solve it for the whole life, that will be part of your real number. And all the integers, like negative integers and positive integers, they are part of real number. And natural numbers are 1, anything greater than equal 1. So those are the natural numbers. And you talk about the whole number includes 0 and all the natural numbers. So basically, under this real number, you have rational number, integers, whole number, natural number, everything. And under irrational number, you have only those fractions that does not have repeating sequence, like you can solve for the whole life. Okay. Now we talk about, let me erase this one. You got the idea? Like what falls under real number and what falls under rational and what falls under irrational, everything. Okay, let's erase this one. Now talk about the properties of real numbers. Okay. So first one is commutative. What does it say? It says if there are two real numbers A and B, these are real numbers, then A plus B will be equal to B plus A, and A times B will be equal to B times A. Very easy peasy. If you have two real numbers and if you multiply them, like A times B, B times A will be same. If you add them in one order, if you add them in another order, they will be same. So order doesn't matter here. It's very simple property. And number two is associative. Okay, associative property. So it says if you have, let's say, three ABC, three real numbers, okay, real numbers, then you can say A plus B plus C is equal to A plus B plus C. Okay. And then A plus B times C is equal to okay, it's A times B times C is equal to, it's again easy peasy. So see, it says if there are three real numbers A, B and C, any number, then you take the sum of first two and then add the third one will be, oh here, sorry, this one A plus B plus C. So here see, if you take the sum of first two and then add the third one, which will be equivalent to take the sum of the last two and then add the first one. Similar for the multiplication. Look at the board. If you multiply the first two and then multiply the third one, will be equal to the, if you multiply the last two and then multiply the first one. It's very easy. But what about, can you apply the minus? Can you say that A minus B is equal to B minus A? Can you say? No. Similarly, A divided by B is equal to B divided by A? No. And here again, can you say A minus B? Okay, forget this one maybe. A plus B minus C is equal to A minus B plus C. Can you say this? No, you cannot say that. Okay. Similarly here, A times B divided by C is equal to B times C divided by A. Can you say that? No. So this is only for the addition and multiplication. Okay. Okay, now there is another property. is the distributive. Third is distributive. Okay, and it says A times B plus C is equal to AB plus AC. It's very simple. Look at the board. A times B plus C, like this is common, so that's why it will be same as A times B plus A times C. Okay, and then we have this is called identity property. Identity. Okay, fourth one, and it says if you add 0 to any real number, that will remain same. If you multiply 1 to any real number, that will remain same. Is it correct? Yes or no? Yeah. If you add 0, it will not change, because adding 0 to anything does not change the value. Similarly, if you multiply 1 to anything, the value does not change. Okay. Next is fifth property is inverse property. Inverse property. What does it say? It says for the addition, if you add the negative value of a real number to itself, it becomes 0. So basically A plus minus A is 0. Okay. And in terms of multiplication, it says if you multiply a real number by its inverse, it gives you 1. Okay. The only condition, can you tell me the condition, what condition should not be here? A should not be equal to 0, because if A is 0, then we have situation 1 by 0, which is undefined. Whenever you see all these types of problems, whenever you see some variables as a denominator, you have to think that, okay, that should not be 0, because if that denominator is 0, then you have the scenario something divided by 0, which is not defined. Okay, so if you see something like this, not only for this example, anywhere, if you see some value as the denominator, some variable, you have to make sure that the variable should not be equal to 0 to avoid divide by 0 scenario. Okay. Anything else? So did you understand all these properties? It's very easy, simple. Okay. Now, what kind of operations you can apply on the real numbers? Operations on real numbers. Okay. So all the basic operations like addition, subtraction, so additions, subtraction, then multiplication and division. You can apply all these basic operations, like let's say here, if I take 2 plus 3 is 5, and then let's say if I have 2 plus 2 square root and 3 plus 2 square root, what will be the value? Look at the board. If I have this 2 square root 2, 3 square root 2, okay? So either you can solve this like 1.414, taking that value, multiply that with 2, multiply that with 3, and then take the sum. Or you can keep this in form of square root of 2. So square root of 2 will be common, and then 2 plus 3 will be 5. So 5 times square root of 2. So this is like a way of, and if you have something, let's say 4 square root of 3 minus square root of 9. Okay, look at the board. 4 square root of 3, square root of 9. So 4 square root of 3. And for these questions, if you are not asked to find the final value, you don't really convert this square root into the fraction. Okay, just keep it in the square root format. So this will remain 4 square root of 3. Square root of 3 is 3. Can you subtract them? You can. For that you have to convert the square root of 3 into fraction and multiply by 4 and then subtract 3. If you are not asked to do that, what you can do, you can leave it in this format. I'm going to give some quiz based on the addition, subtraction, multiplication, division of these square root values. Okay, these real numbers. And these are the basic operations. Similarly, you can do square root of 5 divided by square root of 25. All these things are possible. Okay, so basically any of these 4 operations you can apply to real numbers. And then you can take the square root, cubic root, fourth root, fifth, whatever you want, you can do that. Okay, and cubic roots and so on. Okay, and then you can also apply exponents. So basically, if you have two real numbers, a times b times something like that, look at the board. If you have two real numbers and they have power m, so you can say, okay, it's ab power m. If you have the same base, a power m, a power n, then you can say, okay, it's m power n. If you have division here, a power n, b power n, you can say it's a divided by b power n. And if you have a power m and a power n, then you can say it's a power m minus n. We already talked about exponent in one of the lectures. Okay, so I'm not going into the details. You can watch that video again. So all these operations that you have learned so far, that can be applied to the real number. So I think we are clear about the whole real number system. Okay, let me recap again. So first we have complex number, which comprises both real part and imaginary part. So imaginary part, now look at me. Okay, imaginary part we are not going to talk about. I gave you a basic introduction. Okay, real number, any number that you can find on the number line. Okay, that will be your real number. So real number has two main category. One is rational, another is irrational. Okay, rational numbers are all the numbers you saw, like a whole number, natural number, integers, and some fractions, and fractions that terminates, or fractions that have repeating values. Okay, and irrational numbers are those fractions or those numbers that do not terminate. Like you keep solving and it will go on. So let's say, for example, value of pi is 22 by 7. Okay, and if you try to divide 22 by 7, you will keep dividing whole life. You will not stop. So those kind of numbers are irrational numbers. Basically, it's not terminating anywhere, and even it does not have the repeating sequence. So if it has repeating sequence, like we saw, a divided by b was equal to c decimal xyz, and xyz was repeating. So if it has repeating sequence, then that becomes a part of the rational number. If it does not have repeating sequence, irrational number. So basically, you cannot stop anywhere. Keep solving the value. It will never find an end. So those numbers will be your irrational number, like square root of 2, square root of 3, square root of 5. I think 7, square root of 7 is also irrational. Then pi and base e. We talked in the logarithmic class that they called base e 2.73 thing. That's also irrational number. Okay. So that's all. I think you understood the real number system. Okay.